Hey students, today's lesson is on subtracting integers, and we're going to use a lot of the same methods that we learned when we did addition of integers. So to start with, let's go ahead and model using counters. So when I do 3 minus 7, I'm going to start with 3 positive counters. Now when we were adding negative 7, I would just add 7 negative counters and cancel out the 0 pairs. With subtraction, I'm actually taking away 7 counters. I don't have 7 counters to take away. I need to take away 7 positive counters, and I only have 4. So I need to add some 0 pairs in order to do that. I've added 4 sets of 0 pairs. That doesn't change the value at all. I still have a total value of 3. But when I take away the 7 positive counters, now I'm left with 4 negative counters. So 3 minus 7 is negative 4. Let's go ahead and look at the next example. Draw a line down here. I'm going to start with 8 negative counters. 1, 2, 3, 4, 5, 6, 7, 8. I need to take away 4 negative counters. This problem looks harder, but it's actually quite a bit easier. I have 4 negative counters to take away, so I don't need to add any 0 pairs. I'm going to take away 4 negative counters, minus negative 4, and I'm left with 4 negative counters. So negative 8 minus negative 4 is negative 4. Let's do the last example. 5 minus negative 4. I'm going to start with 5 positive counters. I'm going to take away 4 negative counters. I don't have any negative counters. I only have positive counters right now. So I need to add some 0 pairs, and I need to add 4 of them. Now I have 4 negative counters to take away. I'm going to take those away, and what I'm left with is 9 positive counters. So 5 minus negative 4 is positive 9. Let's go ahead and model these same problems on a number line. So here I have 3 minus 7. I'm going to start at positive 3, that's to the right of 0. When I subtract a positive number, I'm moving to the left. 1, 2, 3, 4, 5, 6, 7. I'm going to end at negative 4. Negative 8 minus negative 4. I'm going to start here at negative 8. Now this is tricky when you're subtracting a negative. Sometimes I like to think of it as you're facing towards the negative side because you're subtracting, but because you are subtracting a negative number, you're walking backwards. So I'm kind of starting here and I'm walking backwards, but facing towards the negative, I actually end up going towards the positive direction. 1, 2, 3, 4. So negative 8 minus negative 4 is negative 4. Here I have another one where I'm subtracting a negative. So let's try that walking backwards thing again. This time I'm going to start at positive 5. I'm going to face towards the negative, but I'm going to walk backwards. I'm going to the right 1, 2, 3, 4 places. So negative or positive 5 minus negative 4 is 9. All right, now, some of you have probably figured this out already, but when we subtract integers, one way to think about this is instead of thinking subtraction, think addition, but of the opposite. So I could change 3 minus positive 7 to 3 plus negative 7. That's the same problem. 3 plus negative 7. Now I can use my rules of addition that I already know and say Since they're opposite signs, I'll do 7 minus 3, which is 4, but the negative integer has a larger absolute value, so my answer is negative 4. Let's do the same thing here. Instead of negative 8 minus negative 4, negative 8, but instead of minus, I'll do plus positive 4. Now I can use my rules of addition. I have a negative number plus a positive number. I subtract their absolute values. 8 minus 4 is 4. The larger absolute value is negative, negative 4. This problem would change to 5 plus, instead of negative 4, positive 4, 5 plus 4, which is 9. So one way to deal with subtraction is to change it to an addition problem, but we have to add the opposite sign. We can do this when we subtract more than 2 integers as well. I'm just going to go from left to right. Actually, let's change all of the subtraction to addition, and then it doesn't matter because addition is commutative. We can do the operations in any order we want. So as long as we change it to addition first. So we'll say 7, instead of minus negative 12, we'll say plus positive 12. And instead of minus 14, we'll change it to plus negative 14. Now we can do it in any order we want. I can say 7 plus 12 is 19, plus negative 14, that's 5. Okay, let's work on the next one. We have negative 9 minus 16. We're going to change that to negative 9 plus negative 16, and then instead of minus 8, plus negative 8. Okay, so these are all negative integers. If we add negative 9 plus negative 16, that's negative 25 plus negative 8. That's going to be negative 33. And then let's do this last one. I'll do it down here because I'm running out of room. 15, instead of minus negative 20, plus 20. Instead of minus 20, plus negative 20. All right, here we have, since addition is commutative, we can do this in any order we want. It would make sense to add these two numbers first because they're additive inverses. So now we have 15 plus 0, which is 15. Okay, last thing, we've got this real-life application. Which continent has the greater range of elevation? So if we want the range, we're going to do the highest minus the lowest. So for North America, the highest elevation is 6,198. And we're going to subtract negative 86. And for Africa, we're going to do 5,895. And we're going to subtract negative 155. Now, in both of these answers, we should end up with a number greater than the highest elevation because the lowest elevation is below sea level. So the range is going to be larger than from 0 elevation to the highest elevation. The range will be a little bit larger. So go ahead and see if you can figure that one out. Go ahead and try the on your own, and I'll see you soon.